Hey guys, and welcome back. Tonight we're going to be talking about solving multi-step inequalities. This is objective 4.6, as you can see up above. Take a moment to make sure your notebook is headed. You can pause the video at any time. So if I move too quickly, just feel free to pause it and then restart. So this seems kind of counterintuitive because we've been working with systems of equations, and now we're moving within the next objective to working with single inequalities. It's kind of a jump. But what we're doing is we're taking a step away from systems of equations and introducing you, since we haven't done that this year, to inequalities, so that over the next couple lessons we can be graphing and solving systems of linear inequalities. So we're going to do basically kind of a couple of review lessons in order to really get to what we need to with systems of linear inequalities. So in this first example, what you'll see the goal today is that we can solve and graph these linear inequalities in your notebook. The first example we have here is d over 7 plus 2 is greater than or equal to negative 4. And the big difference between this and any equation is obviously the inequality sign, or the greater than or equal to sign here. Now, what I'm going to keep referencing throughout this lesson is how is this similar to solving equations and how is it different to solving equations. And basically, it's very similar, except when we get to very specific instances when we're solving. But the implication to the solutions is huge, and we're going to talk about that here in a second. So if this were d over 7 plus 2 is equal to negative 4, I'm going to think about it kind of like that it's an equation. So I'm going to start by doing the first thing I would do by solving an equation by subtracting 2 from both sides. Now, just like in solving an equation, I'm going to bring down everything I have remaining. The 2's cancel, and I'm going to make sure that I copy down this greater than or equal to sign. I want to make very clear, even though we're solving this kind of like it's an equation, it's not, right? So we have to make sure that we're copying everything down exactly the way that it is. This is going to be negative 6. So I'm going to see a lot of students, and I've seen this in the past, write an equal sign here instead of a greater than or equals to, and I just want to make sure that you're aware that that's a common error that we want to be checking for throughout our work. So if this is d over 7 is greater than or equal to negative 6 now by subtracting 2 from both sides, just like I normally would, I'm going to go ahead and I'm going to multiply both sides by 7 over 1 in order to get rid of this denominator. So I'm going to multiply this side by 7 over 1 as well. These factors of 7, one in the numerator, one in the denominator, cancel to give me just d. And I'm going to bring down again the greater than or equal to sign. And then I'm going to put negative 6 over 1 just to make it really clear that this side becomes negative 42. So I've solved this inequality. So now I have a variable on one side of the inequality and just a numeric value on the other side. In this case, d is any number that is greater than or equal to negative 42. So I've done part of the objective here, which is to be able to solve the inequality. And so by having d is greater than or equal to negative 42, I've done part of the problem. Now I'm going to be able to graph. And we're going to be able to graph these on a number line. And I'm going to put here 0 over here on the right hand side, just to denote where this goes from positive to negative integers. And I'm going to go by tens basically. So I'm going to put a positive 10 here. And then over on the left hand side it goes into negative. So this is negative 10. Here's negative 20. Here's negative 30. Here's negative 40. Here's negative 50. Okay, if that's negative 50, then negative 42 is going to be, and let's make this blue. And so this is negative 50 down here. Negative 42 is going to be right about here. And since it's any number is greater than or equal to negative 42, negative 42 is included in the solution set, meaning I could take out d here and put in 42, or negative 42, and negative 42 is equal to negative 42. So it's true. Because it's part of the solution set, I'm going to go ahead and draw a closed dot. Okay, a closed dot, meaning that that negative 42 here is included in the solution set. And then d can be any number that is greater than or equal to negative 42. So if that's the case, I'm going to shade all of the possible solutions, meaning negative 30 is greater than negative 42, negative 20 is greater than negative 42, 0 is greater than negative 42, and 10 is. So any number on this side of negative 42 is going to be a possible solution, meaning it's a number that I could substitute in for D, and it would make the inequality true. So in this example, basically, we were able to solve this down like it were an equation, and we didn't actually see any implication of the inequality until we got down to the graph, where we see that there are infinitely many solutions for this inequality because it's any number that is greater than or equal to negative 42. But now we're going to take a look at example 2. Go ahead and write down example 2 in your notebook. Our goal here is to be able to solve and graph 12c plus 6 is less than 9c minus 15. And we're going to solve this in two ways. So I've split the notebook in half with this black line, just a vertical black line. And on one side, I'm just going to write 12c plus 6 is less than 9c minus 15. And on the other side, I'm going to choose a different color pen here. I'm going to go 12c plus 6 is less than 9c minus 15. Okay, and we're going to solve the left-hand side or the blue side using those best first steps, and then we're going to do the right-hand side without using best first steps. So the best first step, if I were going to solve this, is to subtract 9c from both sides. And it's the best first step, and you can think about this yourself, is the reason why it's the best first step is because it leaves my coefficient here positive. It's going to leave it with a positive 3c plus 6. So 3c, that's a positive coefficient of 3. That's why this is going to be the best first step. And it leaves a negative 15 on the right-hand side. I'm going to subtract 6 from both sides to get all numeric terms on the opposite side of the variable term, which is the 3c. Is less than negative. This is going to be negative 21. And then divide both sides by 3. So I know that c is less than negative 7 here. Again, what we had was a solution, and basically steps to a solution, that were exactly the same as if I had been solving an equation. Except now, when I go to graph this on a number line, I'm looking for any number that could be filled in for c that is less than negative 7. Okay? Very similar to example 1. But let's say we chose a different first step. So I'm going to change to my red pen now. I'm going to solve this one to the right. Let's say I didn't start by subtracting 9c from both sides, but I started by subtracting 12c from both sides. Can you hear Hazel in the background? It's my dog. She's chewing on a chew toy. So if I subtract 12c from both sides, I have 6 is less than negative 3c minus 15. And if I have negative 6 is less than negative 3c minus 15, I'm going to add 15 to both sides to continue to with the idea that I want to get all constants or numeric terms on one side. Here 21 is less than negative 3c. Now if I look at my work equivalent to this step over in the blue side, here the signs are in different places. On the blue equation, the negative sign is with the 21, and on the red side, the negative sign is with the 3. Now I want to continue by dividing like we normally would the coefficient from both sides, and that's going to give me a negative 7 on the left side and a c on the right side. But if I look at the inequality and the position of the constant and the variable, if I bring this inequality down as it is and have negative 7 is less than c, that is not the same as saying c is less than negative 7. So what happens here? Well, what happens is that when we divide across an inequality, so like you will see here, let me change. I've divided across the inequality by a negative 3. So when I divide across the inequality by a negative number, what happens is that the inequality, as it goes down through this negative being divided by a negative, it switches. And it turns or flips the other side. So because on this right hand side I have divided across the inequality with a negative number, the inequality flips as it goes down through here. Now notice on the blue side here I didn't divide by a negative, I divided by a positive 3. And since I divided by a positive number, the inequality stays the same. It stays a less than sign. But when I divided by this negative 3, it switched. It has to flip sides in order to be the same inequality. Okay? So now we're looking for any number, c, that's less than negative 7, or in the case, negative 7 is greater than this number. So here I'm going to start with, let's say 0 over here. And I'm going to go by ones. Copy this in your notebook, please. Where this is negative 1, here's negative 2, negative 3, here's negative 4, here's negative 6, here's negative 8, here's negative 10, and here I would have 1, and then here would be 2. So I'm looking to graph any number that is less than negative 7. So at negative 7, I know I'm looking right here, here's negative 7. I'm going to put either an open or a closed dot. And because of the inequality, where negative 7 is not included in the inequality, I'm going to put an open dot. I know this is not included in the inequality because here the number cannot be equal to negative 7. It has to be less than negative 7. So I'm looking, is negative 8 less than negative 7, or is negative 6 less than negative 7? Well, negative 8, if I'm $8 in debt, that's worse. So negative 8 is less than negative 7. I'm actually going to graph and shade anything to the left because I'm looking for numbers that are less than negative 7 with an open dot because negative 7 is not part of the solution. And the last example today says Ben is moving from Brooklyn to Manhattan. What a poor addition. A moving company charges a one-time fee of $300 plus $200 per hour for its services. Ben wants to spend at most $1,500. What is the maximum amount he can use, or what's the maximum amount of time he can use the moving company? We want to graph. So we have information here. We know that it has a one-time fee of $300, and we know that they charge $200 per hour. He wants to spend at most, that's really important here, $1,500. So if I want to think about what this is saying, Ben's expenses are going to be $200 an hour plus his $300 one-time fee, and at most he wants to spend $1,500. So I'm going to go ahead and define my variable h, and this is going to be the number of hours. Okay, so we know that this is $200 for the number of hours plus $300. At most, he wants to spend $1,500. So here's his total. And if this is his total, we want his total to be less than or equal to $1,500. Alright, so in that case, we know that the inequality sign we want to use is less than or equal to. So this $200 an hour plus $300 one-time fee has to be less than or equal to $1,500, because at most he doesn't want to spend anything over $1,500. If this is the case, we're just going to go ahead and solve this. Let's go ahead and do this here. We'll start by solving like we would by subtracting $300 from each side. I'm left with 200h on the left side is less than or equal to. Notice I subtracted 300 from both sides, but I did not divide or multiply by the negative number. I just subtracted. Only when I divide or multiply by a negative number does the inequality flip. So I subtract 300 from both sides. This is going to be $1,200 on the right side. Divide both sides by 200. And we find that h is less than or equal to 6. Now, keep in mind, when I divide across the inequality, I'm looking here. I'm dividing by a positive number. Because I'm dividing by a positive number, the inequality, when it comes down, stays the same. It stays exactly the same. So he can only have, the number of hours has to be less than, or h is less than or equal to 6 hours. So we're going to write this out. We're going to do it over here. Make sure you copy all this work down in your notebook. Ben can only use the movers for 6 or less hours. He can only use the movers for 6 or less hours. And if we want to graph this on a number line, we would start at 0, 1, 2, 3, 4, 5, 6, 7. Here's 2, 4, 6, and 7. And if it's any hours that are less than or equal to 6, here I have the 6, and I'm going to put a closed dot because Ben can include that 6 in his solution set. The number of hours could be 6, could be equal to 6, but it could be any time less than 6. So it could be 5, it could be 4, it could be 3, 2, 1, and it could even be 0 hours. Now this is interesting because when we get into this tomorrow, we can compound inequalities. But for today, we just want to go ahead and graph this way. So he can use them for just less than 6 hours. Alright, so make sure you have these in your notebook, and I will see you guys tomorrow.